Chemistry, this is the answers video for day 73. This is on the subject of pH and pOH, okay? So what's the purpose of the pH scale? The purpose of the pH scale is to be a user-friendly scale that tells you the relative strengths of acids and bases. So on the pH scale, it ranges from 0 to 14. And 0 is the strongest possible acid, that's a strong acid, and 14 is the weakest possible acid. For bases, it's the inverse. 0 is the weakest possible base, and 14 is the strongest possible base. So it's a nice scale that uses just normal numbers from 0 to 14 instead of hydronium ion concentrations, which are some scientific notation number. So it's just meant to give you a quick reference as to which is a stronger, which is a weaker acid and base. The pH scale is exactly the opposite, except in the opposite direction. The strongest possible base is a 0 on the pOH scale and a 14 on the pOH scale, but we almost never use the pOH scale. I can't think of any time we will. We do use pOH, but we don't use the pOH scale. So we use the pH scale to determine, to kind of understand which acids are stronger than others and which bases are stronger than others. Okay, write the formula. All the rest of these are in the lecture video. That's why it's a pre-assignment. Write the formula that converts here to here. Now where you're going to get that, very simply, is from here, from this sheet right here. Okay? And this sheet is attached to this assignment, and it shows you the relationships. So if you had pH and wanted to get to H3O plus hydronium ion concentration, remember H plus and H3O plus are the same thing. So don't get confused by that. I use two different ones to emphasize that point. They are the same thing. So pH, so if you take 10 raised to the negative pH number, whatever number you had for pH, that'll give you the hydronium ion concentration. If you want to get from hydronium ion to hydroxide ion, then there's a relationship, hydronium times hydroxide ion equals 10 to the minus 14th. So if you knew hydronium and you wanted to find out hydroxide, you would simply say 10 to the minus 14th divided by hydronium, and that would give you hydroxide. Getting from hydroxide to pOH is the same as over on the pH scale. You take negative log of the hydroxide ion concentration to get the pOH, and you take pOH, so you take 10 to the raised to the minus pOH power, whatever that number is, to get hydroxide ion. To get between pH and pOH, that's really the simplest one. pH plus pOH equals 14. So if you knew pOH and you wanted to find out pH, you could simply say 14 minus pOH will give you pH. So so that's what this whole assignment is about, is to learn how to use these formulas and get from, I call these the big four: hydronium ion, hydroxide ion, pOH, and pH. So in a lot of problems in this unit, you'll be asked to calculate all four of these measures. All right, so let's go ahead. So you do these, get these off the video and off of that chart. Okay, so let's go ahead and do a couple of these. All right, so the pH of a solution with a pOH of 9.5, so pH, so it's 14 minus 9.5, and that's going to give you, let's do that, 14 minus 9.5 gives you 4.5. And that's the pH. Okay. The rest of these down here are pretty much the same, pOH to pH back and forth right there. So you do those the same way. This is your base formula right there. Okay, number 12. The pH of a hydronium ion concentration of 4.87 times 10 to the minus 5. So you're trying to get to pH and you're given this. So you take this, it's the negative log of H plus, and that'll give you the pH. Okay, and that's going to give us a pH of 4.3. Okay, so that's a weak acid. All right, let's come down here. Let's do this one, 15. The pOH of hydroxide ion concentration of, which one did I point to? Let's say 15. I'll circle it. Of that one. Okay, and so that's 9.3. So here it is. You want the pOH, and you're given this. So same thing, you take the negative log of the hydroxide ion concentration to get the pOH. Okay, we'll do this one together. So it's negative log up here, and it's 9.03. Let's get that back in focus. 9.03 times 10 caret negative 9, close the parentheses, and that gives us 8 point, we'll call it just 8.0. All right. Okay, there's H3O pH to H3O, so formula is, okay, and that's a pretty easy one to do. It's going to be 10 caret, whoops, back on that, caret negative 5.8, whatever the pH is, 5.8, and that's going to equal that. Well, that's a tiny number, so let's count 1, 2, 3, 4, 5, 6. So we're going to go with 1.58 times 10 to the negative 6, and that's a concentration, so it's molar right there. Okay. All right, so I think you're kind of getting the idea. OH to pOH, so on, H3O. Now, we're getting to some down here where it's two-step problems. So let's go on down to number 21. We'll do this one. I'm going to circle the ones I've done. Okay, so 21, we're going to start with a pH, and we want to end up with a hydroxide ion concentration. So we're going to start here with pH, and we need to get up to this corner up here. We can either do this and come across, or we can come across and go up. I like to use this formula. It's kind of why I put it in red. It's the easiest formula to use. So I'm going to use this first to get pOH, and then simply raise 10 to the negative pOH to get the hydroxide ion concentration. So let's go ahead and do that. That gives us 7.2, which equals pOH. Right there. And now the second step is we need to raise 10 to the negative 7.2, negative pOH. So we're going to do that. And it gives us this number, so we're going to count together. 1, 2, 3, 4, 5, 6, 7, 8. And that is the OH concentration. This whole thing right there. That is the OH minus concentration, and that's that. Okay, let's do another one. Okay, so 23, we're going to start with a pOH of 9.51. So that means this number right here is 9.51. We're going to subtract that from 14 to get the pH, and then we're going to raise 10 to the minus whatever that number is to get the hydronium H3O plus concentration. Let's go ahead and do that. Right, gives us 4.49, and that equals the pH. All right, now we're going to come down here, and we're going to move from here up to here through this 10 to the minus pH. Okay, and we'll do that on our calculator. Okay, and that's going to be 1, 2, 3, 4, 5. So we're going to say 3.2 negative fifth molar equals the H3O concentration. And that's your answer right there. All right, let's do one more. Do the very last one here. So pH, if the OH concentration is 2.21 times 10 to the negative fourth, so that means this number is 2.21 times 10 to the negative fourth. I'm going to take the negative log of that to get the pOH, and then whatever that number is, I'm going to subtract it from 14 to get the pH. Okay, so we'll go ahead and do that. Okay, so down here. Okay, and this gives us a pOH of 3.7. So now we're going to simply say 14 minus pOH equals pH. So that's your answer. pH equals 10.3 right there. All right. All right, that takes care of this answers video. All the other problems are just similar to the ones that we did here, so go ahead and do those on your own.